Hello. Today we're going to look at how we'll compile our speak interpreter to Rust to WebAssembly. So the first thing we should probably do is check out Rust to WebAssembly. I've already checked it out a bit, played out with example code, so which should make things easier as the video progresses. The first thing we should do is install WasmPack, which I've already done, but let's do it anyway. While that installs, after it has installed, the next thing we should check is building a WebAssembly package, how to do it. So we'll jump over all this and go to this section where we should produce Rust functions that JavaScript can call. In our API, in our speak API, we expose an exec method. Where is it? Somewhere around here, yes. An exec method. This can be a single entry point where we have the input stream, and from that we return the output value. This is everything we need for our playground to work. We'll do the token stream and the syntax tree in a follow-up video. So for now we'll just concentrate on purely on the output from the program. So instead of using this, we'll create a function that can call this method. From here, to produce a Rust function that JavaScript can call, we should be aware that most arbitrary types that we've created, like value, will be a bit hard to convert to JavaScript. So instead of returning a value, we should return maybe a string, because a string is basically what we need for the output part. It's like our front end part, so we don't really need to get into the weeds with this one. So what we'll do is we'll create pub fn exec from JS. We'll assume our input is a string instead of a string buffer. An input buffer. So it's obviously an input buffer, but here it's a bit different because it can be streamed input. Here it's not streamed, it's just a string, and it returns a result value, which is the output string, and the error code string, if any. So unimplemented. Okay, we'll implement that. The next part is we have to include our WasmBinds annotation at the top of our call function, or at the top of our function definition. For that to happen, we have to use WasmBinds. I do not have WasmBinds locally, so what we'll do is we'll include it into our project. Let me show the project structure. -54 speak. So about an hour ago, I modularized the speak program such that we have our src which holds the CLI client, and the core holds the core functionality of the speak exposed as a library. This helps us to compile to WebAssembly, as it is a standalone library and not an actual program. So it was a modularization PR. Okay, so with that out of the way, our core has it has the parser and the lexer. What we were looking for is within the runtime library, and it glues together everything. So here we're in runtime. We should actually cargo add, yes, wasn't binding. Okay, let's do that. It's added. Use wasn't binding. Preload. Then we pass the wildcard. Go back here. Okay, so in order to execute our string, we first have to tokenize it, pass it, and eventually evaluate it. We can actually use this function within our JavaScript, within our soon-to-be JavaScript function, or WASM function, or WASM code. So what we should do, this method is implemented by context. So we should first create a context. So maybe context, is there new? Okay, context new, verbose, actually false. So let's create a new context. Let stx doesn't work. Okay, we should pass a reference. Yeah, that's okay. Then we should call our context with exec, then pass the input as a buffered reader. Okay, let's create a buffered reader. Okay, buff reader. Is there new? From, is there from? Okay, from inputs. Can that work? Inputs. Okay, that works. Let's inputs. Then can we create it as a U8? No? Okay, let me check how I did it within the test tab. Tests, evolve. Okay, what did I do here? I created a new context. Okay, then alpytes, buffered new alpytes. Okay, should probably do that instead of trying to pass a generic argument here. Alpytes from. Okay, and I should try to put the buffered reader here. Does that work? Okay, perfect. Our exec function returns us a value and an error, so we should check for that. If it's okay, it's a value. If it's error, it's an error. Okay, the good thing with my implementation is that both these values implement string methods which return string. So doing this should be okay. We should return okay val dot string. string, then error, did I make a message? Let's go to message. Let's take a look at it. For our error struct, we do not have a string method. I should probably message is, I think message is okay. But we do need a reason. So what we should do instead, implement error fn string returns string takes in self, and for that to happen we should create a format where we have our reason. Should reason implement system error, syntax error, return error. Okay, let's create error reason, reason and string, return the string, match reason. Let's put in self, match self, reason, assert, return, assertion, assertion error. Okay, runtime error. This is our string, so we should do to string, to string, to string, reason, syntax, reason. We did the sort. Okay, we did syntax, syntax runtime system. Okay, I'll take care of that. And okay, just to be clean, let's order it as it is here. Should start with the syntax, then the runtime, then the system, later the assertion. Okay, so let's do a syntax. Syntax error. Okay, perfect. Okay, so here what we should do really is we declare the error reason and then the message. So we should have the reason here, then the message, much like we have here, system error, then the message. So here we should do self dot reason dot string self dot message dot string message itself is a string, so it's okay. Right, this is perfect. So error now implements string. Going back, we had an issue here. Instead of message, should do string method. There's still an issue. Okay, strings private associated function. Let's make it public. Input is bytes. Expected buffered reader fund reference for wait. Okay, we had a hello world eval here. So row bytes buffer let buffer new. Okay. So what am I doing wrong? Let me check. Let's L or rather int. Let me declare input. Expected struct path. Arguments to this function are incorrect. Associated function defined here. Sometimes there is an issue with the Rust analyzer. Sometimes I'm not sure this is one of those times. So let's cargo check just to make sure the error is actually an error. Okay, it's an actual error. I should maybe bring up this example from the test and put it within here so that I can maybe be able to compare why this works and the other fails. Okay. Buff reader new input. Maybe I'm using two separate buff readers. Let's check. Okay, just import super. Nothing more, nothing less. Let's check here. Let me change this to CTX. Okay, I think I might be getting. How about I put this into a string? Copy. Oh, I'm using new. Here I'm using from. Okay. That was interesting. Okay. Buffer context equal. Cannot borrow context as mutable. Let me declare this as mutable. I think you're good. Let's try to compile this and see what we get. Okay, let me cargo check first. That's finished. Okay, how do we compile a WebAssembly? We have to create the libtype as dynamic library. See dynamic library. Let's do that. Okay, here. Then later. Okay, let us do the package. Delay presenter. Okay, there is an issue. Right, let's wait for that. That was fast. It's supposed to be core.package. Oh, here we are. We have our WebAssembly code. This is the JavaScript glue code. Our actual function for exec from JS is somewhere in here. Let me open anyway. Okay, it's not code we can read. Here it is, exec from JS. Okay, so let's use it in our code in the next follow-up video. Catch you guys in the next one.